When it comes to surge protection, often we think by putting a surge protection device on the service entrance, all the downstream equipment could be protected. Although a surge protector on the service entrance is a good place to start, the downstream equipment also needs protection. Did you know that 80% of the power surges are generated internally within the facility? In this episode of The Power Grid, we're going to discuss the benefits of cascading your surge protection in order to protect the downstream equipment. Hello and welcome back to The Power Grid, a podcast to help you build reliability in your electrical system and gives you confidence in your power system. I'm Brian Brannigan with Power Protection Products. We have been solving power quality problems for almost 30 years. We are your trusted advisor for critical power, cooling, and energy solutions. Power surges or electrical transients can occur in all areas of the electrical system. Providing downstream protection from your main service entrance can help you with the internally generated surges. 80% of the power surges come from operating the equipment within the facility itself. Motors starting and stopping, welders functioning, even LED lighting all generate power surges within the facility. Providing downstream surge protection can mitigate the damage from these internally generated transients. Most of the internally generated power surges do not make it all the way upstream to the service entrance. Lead length or conductor length is very important when trying to capture these high-speed transients. If the only surge protection device is at the service entrance, the damage will already be done by the time the surge makes it back to the service entrance. That's why cascading, or spreading your surge protection downstream, is very important for protecting your equipment. Let me tell you about a story of a sock manufacturer in central Iowa. This was a large facility with a lot of knitting machines that produced socks of all shapes and sizes. When we were there visiting, the facility manager said, yeah, we got hit by lightning on the far end of the building, and it came through and took out a lot of our knitting machines, and it worked its way all the way back to the main service entrance. We had a surge suppressor on the main service entrance, but we still lost a lot of equipment because of that lightning strike. Is there something that you can do to help? So while we were there, we took a look around and we saw some other electrical panels that could use surge protection and some other equipment that we could put surge protection on to avoid this problem from happening again. And that's why today on the Power Grid, we're going to talk about cascading surge protection devices throughout the facility. And today I'd like to welcome our special guest, Mark Cowart. Mark has been in the surge suppression industry for over 25 years. He's an expert at what type of surge suppressor to put where. Mark, welcome to the show.
Well, thank you, Brian. Thanks for having me. I was looking forward to doing this for quite some time. It's going to be fun to get through this with you.
Mark, I know there's a lot of controversy about just putting a surge suppressor on the main service entrance and calling it good. But we have a whole industry full of electrical engineers that have all come together and have put together something called best practices. Are you familiar with that?
Yeah, the engineers do get together and they get in a consortium and they call it the IEEE, Institute of Electrical and Electronic Engineers. They come out with best practice solutions on how to do things in the electrical world. It has to do with from grounding schemes to surge protection schemes to power factor correction, a whole bunch of different aspects when it comes to power quality and how to ground and do those things for power quality. And surge protection is one of them. Mm-hmm. One of the things that they do is in the IEEE Emerald book, and this is the kind of the book that we follow for best practices when it comes to surge protection. You mentioned cascading surge protection. They actually have a standard for that in the IEEE Emerald book now. That standard that we're talking about comes out of IEEE Standard 1100, and it says the best practice is to stage your surge protection. I wouldn't call it a controversy, but back in the day, what happened is most of the manufacturers thought that you could put one surge protection device on the main electrical panel and everything in the facility would be protected.
Right.
Well, with the promulgation of electronic equipment now spread throughout the entire facility. It used to be you had a main electrical panel, and off of that main electrical panel, they may be fed some variable frequency drives, or they may be fed a control panel on a CNC machine or anything like that, where that was the only source. Now, all that equipment is moved out. All the electronic equipment, the computers and the servers and things have moved out into the manufacturing floor or the industrial floor, and is a lot more subject to transients themselves. Mm-hmm. So when we're talking about transients, most people associated transient with a lightning strike or a utility grid switch. Mm-hmm. Well, what they don't consider sometimes, and it's more prominent now, is that 80% of the issues that we're dealing with are transient surges that are generated internal to the facility itself.
Wait, 80% are internally generated.
That's the figure that they come up with. And if you think about it, the things that are turning on and off in a facility, like a variable frequency drive, like a motor, like even think of lighting, think of lighting. Think of the big CNC type machineries that are turning on and off in a facility and creating a transient that can affect the equipment that's either connected to it or maybe the next equipment downstream of that too. So it can happen pretty easy, and it happens often. Most of the time, what happens is you don't see the bad effect from a transient when it's internally generated. Usually it's called cumulative damage, and that happens on circuit boards and things like that. Some of the things that generate a transient could be something like a transformer turning on and off.
Sure.
You might think of a CNC machine. Well, when you energize a transformer in a CNC machine, you do create a transient that happens and promulgates down through the system itself.
I like rules of thumb, and one rule of thumb is the old 80-20 rule that says 20% of the transients are externally generated and 80% of the transients are internally generated by the use of the equipment. By putting a surge suppressor on the main service entrance only, what's happening to those other 80% of the transients that are generated inside the facility? Are they making it back to the main service entrance, or are they just going into other equipment?
And I can answer that question and say it depends. It really depends on how close that surge protection device is to what it's trying to protect. By our IEEE Emerald book, it tells us to mount a surge protection device as close to the unit as you're trying to protect it. So whether you're protecting on the main panel, you get pretty good protection from the things that are attached to the main panel. However, in your story that you mentioned, you talked about they had a lightning strike down on the other end of the facility that came through another source that did not affect and was not even mentioned or did not even see the main electrical panel.
Right.
So what happened is they probably had something tied to building steel on the grounding system, and a surge propagate in through the building steel by a lightning strike hitting the building.
Sure.
And therefore nothing got protected until it reached a point where it does be able to be addressed by a surge protection device.
Yeah. So our facility is full of transient generators, motors, CNC machines, transformers switching on and off.
Most facilities are.
Right.
Yeah, most industrial and some commercial facilities are. When you think about a residential house, a house or a residential itself, usually the switching that's incurred inside of that usually isn't that bad, and you can address those with plug-in strips and things like that. But when we're talking industrial facilities, sometimes you have very high ampacity equipment that is generating a lot of transients because it's switching on and off or doing whatever it's doing to make what it's supposed to make, and it can create those transients. So that's where we see those, and that can account for 80%, upwards of 80% of the issues that we're seeing in internal into the facility itself.
So let's talk a little bit about the actual surge suppression device itself.
Okay.
These are engineered to take a fast-moving transient and shunt it to ground.
Correct.
So how important is the lead length or the distance that the surge travels before it gets into the surge suppressor?
Lead length is very important. And the reason for that, when IEEE, the same guys that wrote the Emerald book, have a standard on mounting the surge protection device. And their standard, when they measure the voltage that escaped after the surge protection device worked, is called let-through voltage. That's the amount of voltage that escapes that affects the rest of the equipment after the surge protection device works. It's not that the unit will fail. They're not designed to do that until it reaches an amplitude way above its capacity, but they'll continually working. But it's the amount of voltage that escapes after that surge protection device works. When IEEE tests these units, they actually test them with 6 inches of lead length to simulate an actual installation on an electrical panel. They do that for a reason. They want a path of least impedance. We want the surge to go into the surge protection device. Mm-hmm. That's what it's designed for. However, we have ran into installations where they're miles, now I won't say miles, I'll say feet, sometimes 20, 30 feet away from what we're trying to protect, whether that be a main electrical panel, whether that be a CNC machine. Anyone's surge protection device, any manufacturer will want the wire lengths to be as short and straight as possible. Some of the surge protection devices come with wire on them. Most electrical contractors will assume that the wire that's on the surge protection device, go ahead and mount it. Now, if they read the instructions, it will definitely tell you cut the wire lengths to as short and straight as possible. We don't want drip loops in them. We don't want anything like that. We want the wire length short and straight. The rule of thumb is for every foot of wire length you leave on an installation, you let through between 100 to 200 volts of surge getting through to what you're trying to protect.
So if I have a surge suppressor on my main service entrance, mm-hmm. and I have we'll say a CNC machine 100 feet away, and that CNC machine is generating surges every time it processes, is that surge suppressor on the main doing any good for the surges that are being generated internally?
If the CNC machine is fed from the main electrical panel, yeah, you have pretty good protection on the CNC machine part itself. However, that same CNC machine can generate enough transient activity to affect the control of the CNC itself. So it's always a good idea, again, to stage or cascade your surge protection, not just on the main feed. Electrically, when you think about it, the electrical feed on the main service to the point in the CNC electrically is the same point. There's not very much impedance in the wire. It's electrically the same point. However, that can generate enough transients to affect its own control board. So it's always a good idea to cascade your surge protection down and put it in the control power. Mm-hmm. Maybe a 120 volt control, or it could be a 24 volt control, but it's always a good idea to put in at least one more stage of surge protection to protect the delicate electronics equipment that's controlling the same CNC machine.
Sure. Yeah. So they're generating transients inside their own cabinet.
It happens all the time. And that's why a lot of manufacturers of CNC machines back in when they first started doing this and putting electronic controls on them, they didn't have a lot of built-in surge protection. Mm-hmm. Now they do. More and more of them do, and they're putting at least a little bit more surge protection. When it's new, it's always a good idea, though, to replace those after a couple of years, because usually they're putting in the minimum they can to get through the warranty period. And it's always a good idea to replace those and upgrade your surge protection in the CNC controls.
So let's walk through a little bit of this concept of a system shield. Okay, so let's say we got a nice surge suppressor on the main, and maybe it's a 300 Ka surge suppressor.
Okay.
Meaning it can withstand a 300,000 amp hit, or even more than a lightning strike, and it's going to last a long time. Now we get down to the motor control centers, and let's say that those are 2,000 amp motor control centers. What sort of surge protection device would you recommend for that?
Well, typically when you are cascading surge protection downstream of the main panel, you don't really need to have a high of Ka rating on the downstream protection. And the reason for that is that secondary surge protection device should not see a surge of that high of a magnitude mm-hmm. to be able to and have to withstand that kind of magnitude, because it isn't going to see that much voltage. So typically we can cascade it downstream, say on a motor control center. So you can have one unit on a motor control center, one surge protection device on a motor control center that will give you very good motor protection on each of you put one unit on the bus itself, and it'll give you pretty good protection on each individual motor that's connected to it. However, every one of those buckets is probably feeding a different machine that has an electronic control on it.
Right.
So it would be a very good idea, because the CNC machine itself can generate a transient and affect its own controls. It's always a good idea to put a secondary, or we'll call it a third, surge protection device on the controls, because you really want to protect the electronics that are controlling that machine.
Okay, so on the motor control center, a 2,000 amp motor control center, what sort of peak surge capacity would you recommend? If we had a 300,000 amp upstream, what size would you put on the motor control centers?
I'd like to see stuff in about a 160 Ka range. 150 to 160 Ka is what I would normally recommend to be put on something like that. And then going downstream of that, say you didn't have a motor control center, say you had a direct feed into another panel. I would probably say, and even if a motor control panel was fed off to another panel, then you can get by with a little lower Ka rating pretty easy. And I'd say you at least need an 80, maybe a 50 to 80 Ka type of rated unit downstream of that.
And then when we get into control power, we're usually talking about a much less voltage application, 24 volt DC, 120 volt. And
then the nominal voltage coming in, yes.
So you might you could go with a little smaller surge suppressor farther downstream.
You can, but you really need to get an expert involved to tell you what kind you need. I mean, there's different ways to do it, and we can protect downstream at the disconnect, at the 480 volt disconnect or 243 phase disconnect, whatever it might be, with a parallel application. But sometimes it's always might be a better idea, and again, it depends on the application, to put something in series into the motor control, into the control center of that device. So maybe it's 120 volt control. We'll put something in series, so the surge has to go through the surge protection device to be able to do that. What's also beneficial about these surge protection devices is that they have built-in filtering. So it'll eliminate what they call EMI, or electromagnetic interference, that actually affects the controls of themselves. So it actually, I would say, you can almost say it'll clean the power a little bit better because of that capacitance that's in the surge protection device when you put it in series like that.
So this concept of doing a system survey and evaluating what it's going to take to cascade your surge suppression throughout your facility is nothing new. This concept of a system survey is actually an industry standard, right?
It is, and it has been. Fortunately or unfortunately, there's a lot of people in this electrical business that really should call in a power quality expert to do it. And in their defense, it's not something that they specialize in. So a company like P3, our company, we specialize in this stuff. We see it every day. We know what's critical. We know what's not critical. We work directly hand in hand with the customer, with the end user, with the contractor, to be able to walk through the facility with them, and they help us identify what they think is critical, and then we can put on the best unit for the right application. And that's really what it's all about. It's putting on the right unit with the right application.
Sure.
You don't need a 200 Ka rated unit down at a control panel in most situations. And a lot of times, they can throw a lot of different units out on a type of protection scheme, but most of the time there's a better way to do it. And usually it's the most cost-effective way to do it as well.
Right. So by cascading your surge suppression with the right size and type of unit, you're actually not only stopping the power surges from getting in from the outside, but you're controlling the internally generated transients as well and protecting the circuitry that's operating that equipment.
That is a true statement. That is a true statement. However, one thing to also consider is we're just talking about the electrical system.
Right.
Transients do propagate on other things like data lines between the units themselves. So they have a data line that runs in between, and it can carry a transient and affect the control power because it is connected to the control power itself.
Sure.
So it's always a good idea to say, hey, if I'm going to be able to have data communications running between those, it might be a good idea to look at dedicated surge protection for the data stream that you're trying to protect.
Okay, so like 4 to 20 milliamp signal loops.
Anything like that.
Yeah.
Water treatment facilities are a perfect example. We can put electrical protection on the main service. We can put it on the motor control center that feeds all these huge pumps that are out in their wells. But yet they have 4 to 20 milliamp circuit loops out there that are reporting directly back into what we're trying to protect. And it can get hit by lightning, and it does all the time. And it comes back in and it damages equipment, usually not in the electrical part, but on the data side. And so it's usually really important to get somebody out there that can identify that stuff and be able to recommend the correct unit for it.
We called it close all the windows and doors to transient activities.
Exactly right.
Well, Mark, thank you very much for coming out today and talking to us about cascading surge suppression. We're glad we had you here, and we enjoyed the conversation.
Thank you. Thank you for having me.
Thank you for joining us today on the Power Grid. Surge protection placement and sizing can be a difficult task, but P3 is here to help you customize a solution that will meet your needs. Learn more by checking out the podcast notes or going to p3-inc.com.